Hey everybody, welcome back. So today we're looking at networking, IAM, and cybersecurity all together. Now, most people try to learn these as three separate topics, networking in one course, identity in another, security somewhere off in the corner. But in a real environment, they don't work alone, they work together. For instance, your login travels across a network before it ever reaches your identity system. That identity system runs on protocols and ports to make its decisions, and those decisions only hold if the security controls underneath them are solid, which means ultimately each layer depends on the one below it. So if you skip one, conceptually, you'll end up with all these blind spots in when it comes to your knowledge, and it'll be really hard to fix later. So now that we know this deck goes deep and there's going to be a lot of information packed in these slides, it's going to be a perfect opportunity to say that all of it is going to be available for free in the description and in the comments below on TikTok. For now, though, just ride along with me and we're going to walk through the big picture. To do that, we're going to start with what does a network actually do? Now, if we strip away all the jargon, what a network does is actually pretty simple. A network is the road system for data. Logging in, loading a page, pulling a file, launching an app, all of that is traffic moving from one point to another. And every single one of those connections depends on a source, a destination, a path, and a set of rules governing how it gets there. Now, a lot of people learn those pieces as just plumbing wires, signals, and boxes, that stuff moving around, but framing this in this way kind of misses a really big point. Every single one of those connections isn't just a connection, it's also an access decision. That source is a user or a device with an identity. That destination is a resource someone is trying to access. And those rules are what determine whether the connection is allowed at all. So the security question here and the IAM question here, kind of, is never just does the road exist? It's who is on this road and should we let them reach the other side? Once you start seeing networks in this way as access paths instead of just infrastructure, security stops being this separate thing that you bolt on later. It becomes part of how the network is designed from the start. So that is what a network does. But when something breaks on that road, you're going to need a way to figure out where it actually broke. That is where models come in, right? And I know models sound like the most textbook part of networking, but they exist to solve a real problem. When something breaks, you need a way to narrow down where. Think about it. A user calls in and says, the internet is down. Okay, but what does that actually mean? Is a cable unplugged? Is the device not getting an address? Is a DNS failing to resolve? Is a firewall blocking the traffic? Is authentication just rejecting the session? Those are all completely different problems with completely different fixes, and they all live at completely different points in the process. The OSI model gives you 7 layers to organize that thinking. All 7 are on the slide with examples at each level. TCP/IP just simplifies that stuff down to 4, but the model you use matters less than the habit it builds because the real skill isn't just reciting layer names on the exam. It's training yourself to ask, where in the stack is this actually happening? And every single time something goes wrong, okay? That is what's going to separate someone who can troubleshoot from someone who just kind of reboots and hopes for the best. So, now that you have a way to think about where problems happen, the next step is understanding what is actually moving through those layers. So, what is actually moving through those layers, right? Traffic. And traffic follows rules. A protocol is the rule that two systems agree to follow when they communicate, all right? A port is the number that tells them which service that traffic is meant for. When your computer loads a website, it uses a specific protocol to reach a specific port on that server. And the way that conversation gets delivered comes down to two options, TCP and UDP. TCP is the careful one, okay? It makes sure that everything arrives in order and that no data is lost. UDP is the fast one. It just sends and keeps moving. Things like streaming, DNS lookups, voice calls, all of those use UDP because because speed matters more than perfection. Web traffic and file transfers use TCP because you need every piece to show up. The key protocols and ports are all on this slide and you'll run into them consistently. But what matters here is not the memorizing portion, but more about understanding why things matter when it goes wrong. Okay. If a service is unreachable, is the port blocked? Is the protocol mismatched? Is the The traffic even arriving? Those are all troubleshooting questions, but there are also security questions because unusual port activity or unexpected protocols are some of the first things analysts notice and look for. So if something is talking on a port it shouldn't be using, it's probably not a misconfiguration, probably worth investigating. So now traffic has rules and it has a destination, but the network still needs a way to know where that destination actually lives. That is what IP addresses do. Every device on a network gets one, and that address is how the network knows where to deliver traffic. The key details on this are on the screen: IPv4, IPv6, private versus public, all of that. But addresses do more than just locate devices, they also let you organize them. That is where subnetting comes in. Subnetting divides a network into smaller segments, and those segments control who can talk to who. That is not just a math exercise for certification exams, okay? It's one of the strongest tools you have for limiting damage. In cybersecurity, smaller segments mean that if one area gets compromised, the problem doesn't automatically spread it everywhere. That is called reducing blast radius, okay? And in IAM, your network location can actually change what you're allowed access to. A request from inside the corporate subnet might be trusted. The same request from an unknown network might get blocked or require extra verification. So, addressing does not just tell the network where things are, it shapes who can reach what. But an address by itself doesn't really move much of anything. Something still has to forward that traffic from one place to another. Switches, routers, VLANs, and NAT, oh my, all right? These are the pieces that actually move traffic from one place to another. The details for each one are on the slide, but the big ideas tie directly back into what we just covered. Segmentation only works if the infrastructure enforces it. VLANs separate traffic without new hardware. Routers create boundaries between networks, and the way those pieces are arranged determines what can reach what. That is a security decision, whether or not people realize it. Because here is what happens when nothing is segmented. An attacker gets inside, and instead of being stuck on this one small area, they can now move sideways across the network looking for something valuable. That is called lateral movement, and it's one of the most common ways a breach turns into a big one. Good network design prevents that, okay? It limits where traffic can go, which means it limits where an attacker can go. Network design and security design, because of that, are pretty much the same thing. But even the best designs fall apart, okay? If the core services on top of it aren't working. Now, these are the services that make a network function today. All right. You see what each one does on the slide, but there is a way to think about them. All right. If DNS breaks, nobody can find anything by name. If DHCP breaks, new devices cannot join. If NTP drifts, your timestamps are wrong, your certificates may fail, and Kerberos, I always say it wrong. I will forever say it wrong. Authentication can stop working entirely. And directory services are where user identity actually lives on the network. So when people say the network is down, half the time it's actually one of these core services that failed. And every single identity system depends on them being healthy. That is the bridge. Networking is not just plumbing that exists underneath security and identity, okay? It is the thing that they run on. And that brings us to IAM itself. So this is IAM, authentication, authorization, and accounting. The core concepts and the key protocols are on the slide, but what makes this section different from how most people learn it is the context that you already have. You have seen what sits underneath identity, the network services, the protocols, the infrastructure. So instead of learning IAM as an isolated topic, you need to see it as a layer that depends on everything you just covered. And that changes how you troubleshoot. When IAM fails, most people blame the identity platform. The login server is down. The SSO provider is broken. MFA's token is just not working. But a surprisingly big amount of the time, the real problem is not the identity layer at all. It is a networking service underneath that has stopped working. The people who can tell the difference are the ones who understand both layers. And that is a skill that separates you in a real environment. So now you understand what IAM sits on and how it works. The next question is, how do you protect all of it? So how do we protect all of it, right? The controls are on the slide firewalls, ACLs, VPN, segmentation, IDS, IPS. But the mindset behind those controls matters more than this whole list, okay? Traditional security drew a perimeter around the network and assumed that anything inside of it was trusted. If you were on the corporate network, you were in. That worked when everyone was in the same building on the same infrastructure. But it created a dangerous assumption that location equals trust. Zero Trust throws that out, okay? It says no connection is trusted by default no matter where it comes from. Every single request gets verified. Who are you? What are you allowed to do? Can we prove that right now? And if you're hearing IAM in those questions, that is exactly the point. Security architecture and identity architecture are converging into the same thing. The tools on this slide enforce it, but the thinking behind them is what you need to internalize. Okay? And that thinking gets tested the moment users stop sitting inside a protected building. So, what happens when the users leave the building, right? They connect from home networks, coffee shops, airports, personal devices. The wireless and remote access details are on the slide, but the core tension is simple. Every remote path you open is a trade off between convenience and risk, okay? And the further someone gets from your controlled environment, the more IAM has to pick up the slack. Device trust matters more because you cannot guarantee the hardware. MFA matters more because you cannot rely on a network location. Posture checks matter more because you have no visibility into what someone else is running on that machine. This is zero trust under real conditions, not a concept on a slide, but the actual reason those controls exist. The old perimeter did not get replaced by a theory, it just got replaced by the reality that everyone else is remote now, and every connection needs to prove itself. So at this point, you understand how networks are built, how the identity rides on top of them, how we secure the connection, and what changes when users are outside the walls. The next question is what happens when someone is trying to break through them. So, how do attackers actually get in? Six common attacks are on this slide, okay? But the pattern across all of them matters more than any single one. Every attack on this list abuses normal network behavior. ARP spoofing takes advantage of how switches learn addresses. DNS poisoning takes advantage of how resolvers cache lookups. Evil twins take advantage of how devices automatically connect to familiar wireless networks. Attackers do not break networking, they misuse it, okay? They take the same protocols and trusted relationships you just learned about and then turn them into the sideways. And that is exactly why networking knowledge is cybersecurity knowledge. You cannot recognize something abnormal on a network if you do not understand what normal looks like first. That recognition is what separates an analyst from a user, okay? An analyst sees traffic and knows when something doesn't fit. A user just sees the internet's broken, okay? And the way you build that kind of awareness is through structured troubleshooting. So, what does structured troubleshooting actually look like, right? The checklist and the tools are both on the slide, but the principle behind them matters more than any single tool. When something breaks, do not guess. Work through it in an order. Stare at the bottom and move up. Physical first, then addressing, then DNS, then reachability, then ports, then authentication. Okay, that sequence should feel familiar because it matches the layers we walked through earlier in this deck. Now, the model is not just a concept, okay? It is your troubleshooting method. And here is the thing that catches people off guard in real jobs, all right? The symptom is almost never going to tell you the cause. What looks like a networking problem is often a DNS issue, a certification mismatch, or a policy blocking something it shouldn't be. The people who chase the symptom are always going to stay stuck. The people who work the layers to find the actual problem, going system by system, that process is going to be more efficient for you. Everything we have covered still applies even when the networking stops looking like the traditional, okay? Keep that in mind. So, what does the network look like when it is not super traditional, which we kind of talked about? This one is a little bit different. We're going to be talking about cloud platforms, software defined infrastructure, distributed connections across multiple sites. The modern concepts obviously are on the slide. Cloud networking, SDN, SD-WAN, SASE, and infrastructure as code. all that stuff. But none of them replace what we have covered, okay? They extend it. The same principles of addressing, segmentation, protocols, identity, and security, all of that stuff still applies. They just live in environments where the infrastructure is virtual, the users are everywhere, and the network is managed through code instead of hardware. That is why these concepts are at the end of this deck and not at the beginning. They make a lot more sense once you've already started to understand what they're built on. And the certification exams obviously agree. Networking Plus added SDN, SD-WAN, and SASE and IAC to the latest objectives because this is where the industry is heading, okay? So if you are studying for any of these exams, the next slide gives you a framework for how to think about every single topic that we have covered. Well, here we go. So here's the framework, all right? The exam breaks down right here on the slide. But the way you use them is what matters, all right? For every concept you study, run it through 5 questions. What is it? What does it do? Where does it break? What security risk does it create? How does identity tie into it? If you can answer those 5 things for any topic, you are not just memorizing, you are thinking the way that the exams actually test you. Network Plus, Security Plus, CCNA, all throw scenarios at you, not just definitions. Okay? They want you to know if you can look at a situation and figure out what's going on. And here's the thing, every single concept in this deck fits that pattern, okay? Protocols, ports, addressing, segmentation, infrastructure, core services, IAM, security controls, remote access, attacks, troubleshooting, cloud. Run any one of these through those 5 questions, and you're going to see how all of that stuff connects, and you're going to actually feel more certain in the topic. Now, that has been the point of this entire deck, obviously. Networking, identity, and security. They're not just these 3 off the cloud separate topics, okay? They are one system. And the people who understand that are the ones who are going to stand out. Now, if you want to keep going, everything in this deck is built right here, okay? All 6 sources are linked on the slide, official certification pages and exam documents. If you want to go deeper on anything that we covered, please start here. And remember, the full slide deck is in the description and pinned in the comments below. So save it, screenshot it, study from it, whatever works for you. But most importantly, thank you for watching. Go build, run your questions, and start connecting the pieces. I'll see you in the next one. Bye.